How's it going, everybody? My name is Snazzy Patty, and today we're checking out a video called Could the Big Bang Happen Again? I sure hope not. Genuinely, that is terrifying. Space scares me enough as it is. But anyways, this video is by Astro Kobe. Link is in the description. Go check him out. But as always, man, let's just lock the hell in.
Okay, I have something important to tell you. Right now, the universe is expanding, and that expansion is getting faster. For 25 years, physicists thought this acceleration would just never stop, that the universe would expand forever until every star burns out, every black hole evaporates, and all that is left is cold, empty nothing. The heat death of the universe. But just last year, this telescope in Arizona mapped 14 million galaxies and found something.
How is that possible? How can a telescope see that far? I don't understand how space telescopes work, or the NASA telescopes. I don't understand how any of that works. Like, I know, like, telescope, obviously it's zooming in like binoculars or something. But how does glass get something to, like, is there more, like, is there some type of computer shit going on, I'm assuming? I don't know. Someone let me know.
Nobody expected. The force pulling the universe apart appears to be getting weaker. And if it keeps fading, gravity eventually wins. The universe stops expanding, reverses, and collapses back in on itself, crushing every galaxy, every star, every atom in your body into a space smaller than a proton, the Big Crunch. But something else genuinely kept me up at night when I was researching for this video. Some physicists think the story doesn't stop there. They think the crunch triggers a brand new Big Bang.
Well, yeah, because if it condenses small enough and matter cannot be created nor destroyed, it would condense small enough and become so strenuous that it would just boom! And that's the Big Bang.
New universe born from the death of ours, the Big Bounce. So in this video, we're going on a journey to the end of time to see how the death of our universe could actually result in the birth of another.
Do you guys think that would, like, make it so where, like, everything is just constantly repeating? Like, I've lived this exact moment right now. You've watched this video that you're watching at that exact time you're watching it at a million times before, and this just keeps happening? Do you think that's, like, a thing? You know? I feel like that's a pretty crazy conspiracy.
Billion years ago, everything in our universe was much closer together. And I mean everything. Not just the galaxies and stars, but the space.
That could explain why we randomly feel deja vu out of nowhere for no reason. Or, like, you know, you think you've relived a moment, or like you've been here before, you've done this before, and you're like, wait a second. I get that a lot. Like, once, like, in a blue moon, I'll get, like, it happens to me 3-4 times in a week, and then not again for like half a year. It's weird.
That those galaxies exist within was squished together tightly. And then the universe expanded. If it started out at the size of a marble, it grew to the size of the observable universe in less than a trillionth of a trillionth of a trillionth of a second. The classic idea of a Big Bang singularity was popular for a long time, but recently scientists have started to favor an alternate theory: cosmic inflation. I have a full video all about this that you should watch after this one, but for now, all you need to know is the universe was squished together really tightly, and for some reason we still don't quite understand, expanded into the massive universe we can see today. In the early 1900s, physicists figured out that the universe was expanding, so they immediately started thinking far into the future, billions and billions of years, to try and figure out how the universe might end. And there was one idea that stood above the rest, because the logic was simple. If there was enough stuff in the cosmos, then gravity will eventually win. As the universe expands, it will slow down as gravity starts to take over. One day, it stops and reverses. Think of it like throwing a ball straight up into the air. You throw it, it rises, and then it falls back down to the earth thanks to gravity. Well, the universe could do basically the same thing, expanding outwards and then collapsing back in on itself. This was the idea of the Big Crunch, and for decades it was the leading theory for how the universe will end. But like I said, some physicists took this idea even further. They asked, what if the universe doesn't just collapse? What if it bounces? The idea was incredible. The universe expands, gravity eventually pulls it all back together in the Big Crunch, but instead of it being crushed into nothingness, the extreme conditions at the bottom trigger a brand new Big Bang. A new universe is born from the ashes of the old one. And if that could happen once, Why not again and again and again? Some physicists imagined the universe going through an infinite series of these cycles.
So just like how I was just like, what I was just saying.
Expanding, crunching, bouncing, expanding over and over forever. Later in this video, I'm going to walk you through exactly what the Big Crunch would actually look like step by step and show you what happens at the very bottom when the universe tries to bounce. But first, there's a problem because in 1998, both of these ideas were basically killed. As some of you have probably noticed, the office I'm in looks a little bit different now, and it's actually because I recently moved overseas from Australia.
Oh, we got a sponsor. I really don't care. There we go.
I think nobody expected. The universe's expansion isn't slowing down, it's speeding up. Something was pushing the cosmos apart faster and faster, and nobody knew what it was. They called it dark energy, and it makes up about 68% of everything that exists. This was obviously...
Do we still not understand what it is or what it's made up of or anything like that? Dark matter is what really terrifies me. The unknown is scary enough as it is, but like more than half the universe is made up of this unknown material. Are you kidding me?
Devastating for the Big Crunch. If the expansion is accelerating, then gravity just never wins. The ball you threw into the air doesn't just keep rising, it's got some kind of rocket attached to it that flies it off into space. It never comes back down. And if the universe never crunches,
What I can't comprehend, right? What is space sitting in? What is this, right? Like, I just can't comprehend that space is in something or whatever, right? Like, space is everything. So how can it... Like, when we're talking about space, are we talking about just all the material that's in space? Right? Because when that's all gone, like, there's still... Like this, right? This right here, this invisible shit, right? Like, there's nothing here. Yes, there probably is particles and atoms and stuff flying around right now at micro levels, but when that's all gone, this invisible, like, what I'm fucking waving around in right now will still be here. Nothing else will be, but, like, I don't know. It's just so... I can't comprehend space. I'm too stupid for this.
certainly never bounces. No crunch, no bounce, no new Big Bang. Both ideas were dead in the water. Instead, the universe expands forever. The stars burn out, the black holes evaporate over unimaginable timescales, and eventually you're left with nothing but an incomprehensibly vast, cold, and empty void. That's the heat death of the universe. Basically, nothing forever. For 25 years, this was the answer. Case closed. But here's where things get really interesting. In 2020,
Alright, talk to me.
Dark Energy Spectroscopic Instrument, or DESI, a massive telescope survey based in Arizona, released data that sent shockwaves through the cosmology world. DESI cataloged the positions of over 14 million galaxies
echolocation?
and quasars, creating the largest 3D map of the universe in history. Using this map, they measured something called the Bow scale, which is the key that unlocks...
Can I look at this map online? Like, can I, like, click and zoom in and all that shit?
whole discovery, so stay with me. During the first 380,000 years of the universe, there was no empty space. Everything was one enormous soup of plasma, and sound waves were rippling through that soup, just like sound waves traveling through air. Gravity was still working. Any areas with more stuff would clump together and try and collapse under gravity, but this force would be quickly counteracted by radiation pressure, the light itself pushing against the soup. This interaction is where those sound waves come from. When the universe finally cooled down enough to allow for the first atoms to form, the plasma turned into a huge gas cloud, and those sound waves were frozen in place. They couldn't travel through the soup anymore. It's as if you dropped a stone in a lake and watched the waves ripple out, and then all of a sudden, the lake froze solid. Now, here's where this gets crazy. These patterns align with where the galaxies preferred to form. right there in the center, but also out here in the peaks of these sound waves. We know exactly how big those ripples were when they froze, so by mapping where the galaxies are now, we can measure how much of the universe has stretched since then. And because light takes time to travel, looking further away means looking further back in time. DESI mapped galaxies across 11 billion years of cosmic history, and when they measured how the universe was expanding at different points in time, the result was surprising. The data suggests that dark energy is not the unchanging constant that we thought it was. It appears to have been stronger in the past, and it's getting weaker now.
I mean, that's somewhat comforting, I guess.
But I have to be careful here. In science, there's something called a 5 sigma detection. It's how physicists measure confidence that an observation isn't just random chance. 5 sigma means there is only a 1 in 3.5 million chance that what you're seeing is a fluke. It's the gold standard. Once a result crosses that line, it becomes a discovery. Now, depending on how the DESI data is analyzed, this current finding sits somewhere between a 2.8 and a 4.2 sigma. So it's getting very close. But if it's true, this changes everything about how the universe will end. The Big Crunch and the Big Bounce are back on the table. I'm gonna make a full video deep diving into this DESI discovery and dark energy soon, so make sure you're subscribed for that. But now, let's get to the really fun part. So, what would it actually look like if gravity won? Let's walk through it, step by step, from the first signs to the final moment. At first, we would notice absolutely nothing. Even if dark energy weakened to 0 tomorrow, it would take billions of years before the effects became visible. The universe would still be expanding, just slower each century. Eventually, billions...
See, that's the one thing I like about space, though, is that everything takes so fucking long to happen that I'm gonna be dead way before all this.
Of years from now, the expansion would grind to...
Like, the only thing I could think of that would happen out of nowhere to, like, end us in my lifetime would be an asteroid somehow getting hit by something going off trajectory into us, right? And, like, we don't have time to prepare for it, but we would still probably have a couple years and all over. I feel like the world would try to come together and, like, shoot lasers and nukes at it to not even just blow it up maybe, but to, like, to push it off of our trajectory or something. I don't know. We would figure out something, I feel like. Or at least try to. I don't know how confident I am. But also, like, a black hole, maybe. Like, you know how a lot of scientists be messing around with trying to create black holes and stuff like that for funsies, I guess? Just to see. I have no idea why they're doing it. Imagine they just make one that they just can't contain or control or something, and it just sucks the whole planet from within. Done. That would happen instantly, too, because it's on our planet, so, like, the time dilation wouldn't be in effect, I feel like.
Halt. If you had a cosmic speedometer, the needle would hover at 0. The universe holds its breath, and then slowly, it starts to contract. Contraction looks like expansion, but played in reverse, just at an agonizingly slow speed. The distances between galaxy clusters start shrinking, so gradually that nobody inside the universe would notice for billions of years. But here's what makes the contraction different from expansion. Expansion spreads things out and cools them off. It gives the universe room to breathe. Contraction does the opposite. Gravity pulls everything closer together, and as it does, the universe heats up. Distant galaxies that had been flying away from us begin to blue shift. Their light gets compressed instead of stretched. The cosmic microwave background, that ancient afterglow of the Big Bang that currently sits at 2.7 Kelvin, just above absolute zero, starts getting warmer. Galaxies start to collide more frequently, and when they merge, they will light up bright blue thanks to new stars being born. And new planets form too, but surrounded by so many supernovae that their surfaces are sterilized clean. This is the point where new life can no longer form in the universe. As the universe collapses, the CMB continues to get hotter. 3 degrees, then 10 degrees, then 20. But it's not alone. The light from these stars and brightly glowing black holes gets compressed too. As the universe recollapses, the cosmic web of stars and black holes throughout our galaxy heat up faster than the CMB. All of their light from the last few billion years gets progressively squished closer and closer together and...
See, these clips like this is what terrifies me about space. This shit doesn't look at all normal. Like this... Bro, imagine seeing this, bro. I mean, you wouldn't. You'd be dead, right? But like, oh my god.
Things start to get messy. This radiation will ignite the surfaces of stars long before they even collide with one another. Every planet in every galaxy becomes a charred, lifeless rock. The only safe place now for humanity would be the empty space between galaxies. As the contraction accelerates, the heating accelerates with it. It's a runaway process. Gravity pulling things closer.
So if we were somehow alive by now, we would have to be on some like the 100 shit flowing in space and shit like that. I doubt human species would be around still 20 billion years from now. I seriously doubt that. Like, I would bet everything on that. Like, shit, even if you gave us 1 million years, which I don't think we will hit 1 million years or whatever, We would be in space by then. We would be a space colony civilization, I feel like, or at least we would be on the verge of like fully adapting. You know what I mean? Like we'd already be transitioning into a space colony type of like civilization.
Pulls things closer faster. The CMB heats up past the microwave spectrum into infrared, then into visible light, then ultraviolet. The entire sky becomes a wall of radiation. There's no night anymore. Every direction you look is light and heat, getting brighter and hotter every moment. By now, the temperature of space itself is climbing past the surface temperature of stars. Stars can no longer radiate their heat away because the space around them is hotter than they are. They swell, break apart, and dissolve into the surrounding plasma. Galaxies that took billions of years to form get crushed together in a cosmic pileup. Individual solar systems are ripped apart. Planets have long since been destroyed. Then the atoms themselves start to break. The temperatures climb past billions of degrees, smashing electrons off their nuclei. The nuclei themselves crack apart into individual protons and neutrons. Then those break down into quarks and gluons. The entire universe becomes a shrinking ball of quark-gluon plasma, the same primordial soup that existed in the first microseconds after the Big Bang. Everything is hotter, denser, more extreme with every passing moment. In these last moments, the universe is collapsing together faster than light. Space itself is shrinking. The density and temperature are climbing towards infinity. If Einstein's equations were the whole story, this ends in a singularity, a point of infinite density where time itself stops. But most physicists today don't think that would actually happen. We already had this same problem.
How can time stop? Sure, maybe things may stop aging, right? You know, stuff like stops aging somehow. Time would still progress, would it not? See, that's another thing I can't understand either. Like, obviously, the whole construct of time is relevant and man-made when you really think about it. Like, we give definitions to it all, right? 60 minutes being an hour and 60 seconds being a minute or whatever and all that. Like, a minute doesn't exist. None of that exists, but something is happening. Time is moving forward. Things get older as time moves forward, but we don't know what time really is. Like, you know, it's weird.
With the Big Bang, and the consensus now is that singularities aren't real physics. They're what happens when you push equations past their breaking point. So what actually happens at the bottom of the crunch? At those extreme densities, Einstein's equations just aren't enough. You need quantum mechanics, and the most developed theory of what happens, loop quantum cosmology, predicts something extraordinary. At normal densities, gravity is attractive. It pulls things together. That's what drives the crunch. But at an absurd density called the Planck density, quantum effects in the geometry of space itself generate a powerful repulsive force that overpowers gravity completely. To give you a sense of just how dense this really is, take the most massive black hole we have ever found, TON 618.
What?
66 billion times the mass of our sun. Now squeeze all of it into a ball 5,000...
That exists. It's in the universe, in somebody's galaxy right now. So they just get bigger and faster. They grow faster and bigger as time moves on because they're just sucking up more and... You know? What? This better be like at the other side of the galaxy. Like, you know what I mean? Other side of the universe or whatever. Space.
Times smaller than a proton. You've just reached the Planck density. It's like the universe has a built-in trampoline. You can fall towards the ground faster and faster, but at the very bottom, instead of hitting the floor, you bounce. The singularity gets replaced by the Big Bounce, a smooth quantum bridge between a dying universe and a newborn one. All of that compressed energy from the crunch gets converted into raw material for the new universe. In a fraction of a second, the ultra-dense state explodes outwards, a brand new Big Bang. The universe now goes through the same stages that ours did. Impossibly hot plasma fills all of space. Over hundreds of thousands of years it cools, atoms form, light breaks free, gravity sculpts matter into stars, galaxies, and maybe even eventually, planets. But here's the incredible part. This universe would almost certainly look nothing like ours. The quantum fluctuations that seed where galaxies form are random, so the new cosmos would have a completely different map. Different galaxies, different solar systems, different everything. And in some models, even the fundamental constants of physics get...
That's pretty cool then, because you get to think and theorize what type of alien life would happen. Like, Everything's on the table now. All possibilities. Like, couldn't there even be new, like, laws of the universe and stuff like that after that happens?
Reshuffled at the bounce. The strength of gravity, the mass of the electron, the speed of light. You could end up in a universe where stars can't form at all, or one where chemistry works in ways we can't even imagine.
Yeah.
Every bounce is a brand new roll of the cosmic dice. And
It's like a different, like, alternative version of, like, multiverse theory. It's weird.
this leads to probably the most profound question of all. Has this happened before? If the universe
Yeah.
why not forever?
That's an existential crisis right there.
Princeton have spent decades developing cyclic models where the universe goes through an infinite series of these expansions and contractions. Each big crunch leads to a new Big Bang, and over again. In this picture, our universe isn't even a story. It's one chapter in a book with no beginning and no end. Now, you might be thinking,
that just makes me even feel smaller. Like, I already knew we were like an atom compared to the universe. Smaller than an atom compared to the scale of the entire universe. And, like, how long humans have been around is even smaller. And it's just, like, just more and more I learn how small we really are.
this sounds pretty incredible, but is any of this actually testable? I mean, we're trying to do science here. And the answer is, amazingly, yes. The cyclic model makes a bold prediction. Primordial gravitational waves should be essentially undetectable. A future mission called Lightbird, being built by Japan's space agency, will look for this exact signal. If they find strong gravitational waves, the cyclic model is dead. But if they find nothing, that's evidence in its favor. And DESI is still collecting data right now. ESA's Euclid and the Vera Rubin Observatory are coming online to measure dark energy from completely different angles. Within the next few years, we should know whether dark energy is truly changing. And if it is, the big crunch goes from a thought experiment to a reality. And even crazier, if quantum gravity is right, it doesn't end there. The universe bounces. New space, new time, new galaxies, new stars, maybe new physics entirely. Every bounce is a brand new roll of the cosmic dice. We might not be living in a universe. We might be living in one heartbeat of something that has no beginning and no end. And the instruments that can prove it are collecting data right now.
So we might be able to figure this out within our lifetime. Like, me and you guys watching this. But my mind is blown. I'm having an existential crisis over here, man. All of the above. This was an incredible video, man. Astro Kobe, what a banger, man. Make sure you like, subscribe, put on those post notifications. Go check out the original video. Link is in the description below. Make sure to go check out my Twitch. Link is in the description below. We sometimes do these reactions live on Twitch along with gameplay and all that type of stuff, man. So make sure you go check that out. I will see you guys in the next video. Stay safe, stay snazzy, stay blessed.